All right, so 23.4 plus 45.67 plus 3.012. All right, I got 72.082. Did anybody else get that? Yeah? All right, so the rule. How many places behind the decimal? Here? Here? So I want how many there? 1. So you can either round it up to 72.1, which would be correct, or I would take 72.0 if you just dropped it off and didn't round. All right. 14.30 times 3.01 divided by 0.035. I got 1229.8. All right, so the rule for multiplying and dividing. So how many? 4, 3. So what'd you put? 1200 works. Okay, that's what I do too. 1.2 times 10 to the. Yep. 1.2 times 10 to the third, if you did that. All right, and the third one, these on the quiz have to be in scientific notation. I'll tell you that now. So 3.45 second EE 5 times 4.3 second EE -8. All right, mine's not in scientific notation, so mode. 1.4835 times 10 to the -2nd. All right, so we're doing this in scientific notation. We did what operation here? Multiplication. How many significant digits? 2. How many here? There's 3 here. How many here? So I need 2. So what did I round to? All right, 1.5 times 10 to the -2nd. If you did not, and you rounded to 1.4 times 10 to the -2nd, I will not mark it wrong. I will not. All right, so number 3, what's the formula? K equals C plus 273. So 225 equals C plus 273. Subtract 273 from both sides. -48. It does not feel -48.
It is.
All right. So from there, Celsius to Fahrenheit. All right. So 18 Celsius equals 5/9. F minus 32. What did I tell you to do? Cross multiply. 18 times 9. 162. 1 times 5 is 5. F minus 32. I tend to like smaller numbers, so I divide by the 5. So I get 32.4 equals F minus 32. Add 32 to both sides. 64.4 equals F. All right, I had a whole number of 18. So for my significant digits, I need only how many? 2. So 64 degrees Fahrenheit. Questions?
I did that really well. My handwriting on this.
All right, everybody there? Before we talk homework?
Wait, I have a question. If you have to do the significant, or if you have to do the scientific notation, say it's like 0.04418, blah, blah, blah.
Hold on, let me write it down. All right, so it's point what?
0.4870001.
0.04 what?
Just any random number, to be honest.
And I have to do what with it? Put it in scientific notation?
How would you turn it into the scientific notation? Would you just drop the rest of the stuff?
4.87014, and then round it to however many numbers you want. So how many numbers you want in it? So keep these two. So 4.8, and then you can round up if you want. And then times 10, we moved it how many places? To the negative second, because we moved it to the right.
I didn't know if you had to consider all the other stuff.
No, you just drop it off. Okay? All right. Everybody ready to look at homework now?
Yeah, definitely.
All right. So number 1. And number 1, you need no places behind the decimal. So you can round to 32, which is correct, or you could leave it at 31, and I will not mark it wrong. Number 2, you need one place behind the decimal. You should round to 84.7, but if you left it at 84.6, I will not count it wrong. Number 3, you should round to 2 significant digits. So decimal 96. Number 4, again, 1 significant digit. So that 171 should be rounded up to 200. You could have even said, 2 times 10 to the second. Now, if you rounded down to 100, I will not mark it wrong. But 171 really should not round down to 100. Number 5, you need 3 significant digits. So 10.4. Number 6, we're doing scientific notation, but we're using places behind the decimal. So after you add, after you add and you get the number, okay, it has to be in scientific notation. Okay, so add and get the number in scientific notation. You get 8.304 times 10 to the 5th. Now, how many numbers are behind the decimal in the first number? 2. Now, 1.45 has 2 behind the decimal. The next one, the 6.854, has how many behind the decimal?
3.
It has 3. So I want that one to have how many behind the decimal?
2.
So I'm keeping the first 2 behind the decimal, so I'm keeping these 2. So 8.30 times 10 to the 5th. Okay, you use the same rules. Number 7. Again, put it in scientific notation on the calculator. So you get 3.875 times 10 to the 5th. All right. And you need how many significant digits? Well, how many do you have in 2.015?
4.
And how many in 5.2?
2.
So we're going to keep the first 2. Now, if we follow Nakaya's rule, that should round up to 3.9 times 10 to the 5th. But if you left it at 3.8 times 10 to the 5th, I will still take it because it has the right significant digits. Okay? Number 8. You're dividing. You've got significant digits. You should have 2. You should have 1.8 times 10 to the 6th. But if you left 1.7 times 10 to the 6th, I will take it. You don't have to. That's sort of a lot of zeros. So I guess if you have what? That would be how many zeros? 5. So 1,800,000?
So scientific notation, 1.8 times 10 to the 6th.
Yes. So I mean, if you have that, I wouldn't mark it wrong. Okay? But when you get numbers that large, that's the purpose of scientific notation.
So you want this.
When you get numbers that big, I would really like for you to put those in scientific notation. That's its function. Or if you get numbers that are like, put that in scientific notation. That's its function. Okay? Number, where were we? It's 9. So we need how many numbers behind the decimal? We need 3. So 58.971. If you left 58.970, that's fine. Number 10. This one has to be in scientific notation. 4.32 times 10 to the 11th. If you left 4.31 times 10 to the 11th, that's fine. 11 is 16. You want no places behind the decimal. If you rounded down to 15, I would take it. Number 12, 140, because you only want 2 places behind the decimal, or excuse me, no places behind the decimal. And, sorry, I'm doing the wrong rule. We're doing significant digits, we only want 2. And so 141 would give you 3, so you got to round to 140. Number 13, we need, looks like just 1 significant digit here. So 0.02. If you rounded to 0.01, I would not mark it wrong. Anybody put in scientific notation? 2 times 10 to the negative second. All right, and the last one. This one is going to be a large number, so it needs to be in scientific notation. It's not a big number?
No.
Okay. I got 7.77 times 10 to the 14th.
I had 7. I think I forgot to write times 10 to the 14th. I had 7.7.
7.77 times 10 to the 14th. Now, you need 3 significant digits there because you have 4 in the first number. You're dividing, and you have 3 in the second number. So you need 3 in your answer, which is why I said 7.77. All right. Questions about any of those? Good. Anybody else? Questions? The last one. All right. So when you punch it in your calculator, all right, you have to put in 6.25, 6.235, second in EE, and then 6, and that's a divide sign, and then 8.02, second in EE, and you have -9, and when you hit equals, you get a whole bunch of weird numbers. All right, 7.77. 431, so forth and so on. And at the end, it has that E, so times 10, and you have the 14, which is what Annabelle said she missed, okay? So when you apply the rule, we're dividing, and so the rule for division is the least number of significant digits. So how many do you have in the 6.235? How many significant digits there? 4. And then in the 8.02, you have how many there? So we only want 3 in our answer. So what numbers are we going to keep? Yep. So you're going to keep 7.77 times 10 to the 14th. Anybody else? Question on the homework? So we feel okay about significant digits for the quiz? Well, if you don't have any questions about the homework, I wouldn't think you have any questions about the quiz. Now, the only thing you need is a writing utensil and a calculator. There's nothing on the orange paper that's useful because you're just literally calculating and rounding. Okay? It's just 10, multiply, add, divide, subtract. Nope. Not all this.
Basically, I have 2 periods of math. And
It's not all math. It just is right now.
It's all math.
The whole course is not math. It just is right now.
We never do anything fun in here, so technically math.
You're never going to do anything fun in here, so technically.
Math.
But we won't do anything fun that's not math also. We'll do stuff that's completely boring that's not math also.
Where's that?
It's just dreary that you won't enjoy it.
We can play with fire.
Yeah, you'll get included fire. I was up for it.
That ain't right.
Maybe twice.
Let's just hope I don't get right out of school. I'm late.
Here, I was fire.
Y'all see that vine? Welcome to physics. That's what we do.
Now, there is no partial credit on this quiz.
Oh.
If you make a calculator error, it's automatically what?
Zero.
Wrong. Not the whole quiz. So I would recommend punching it in twice, because even if you round to the correct significant digits, if you punch it in wrong, it's automatically a wrong answer. Okay? So double check yourself and make sure you calculated it correctly.
Maybe I can do 83 on this. Oh, no, I can't.
They're in whole numbers of 10.
I didn't see that.
Okay. Just checking. After the quiz, Caleb, I'll make these copies for you real quick in case they add anybody else. So I've got originals. Maybe you're still working. Okay, that's quite a bit. Put your hands down. That ain't good. How about that? Thank you. Go ahead. How many of you are working now? Is that everybody? Okay, special purpose to the front.
Oh.
How bad working?
I went back and went over all of it and I ended up thinking like 3 again. I don't know what it is. I guess I just clicked wrong numbers.
Let me make a couple copies for Caleb now that y'all are done with that quiz. And while I'm doing that, y'all find your notes.
I need to go find the exam of those and the math one. The color coded. Yeah, there's a lot of people. Whenever I was younger, I think that I remember you. But there's a one that comes with fire.
I want South Mexican.
Maybe. Yeah, because they don't, because some of the girls, everybody comes out and does it, they don't have to put on the fire. I'm not saying that everyone there's some special.
You sure you didn't?
I didn't see the start over.
I went to Southwest.
Yeah, right the next.
Southwest.
You also know that.
I like stuff like.
It's just like stuff, man. I think I need to take care of my something. And it hurts. Cause I wanna get like a star and stuff.
I want my second.
All right, so what did we stop on yesterday? Heat?
Yeah.
All right, so we were talking about heat and temperature, right?
Last thing we bought was the equipment for heat, and then you realized it was 11:38.
All right, so yesterday when we were talking about heat and temperature, just to review very briefly. No, I'm just hitting some highlights. This is just review. I'm just hitting some highlights. You've already got this in your notes, with the exception of Caleb because he's new and wasn't here yesterday. All right, so yesterday when we talked about temperature, what was the key word for temperature? All right, average kinetic energy. What was the key for heat? Sum of the kinetic energy. Yeah, it's in the definition. I'm just telling, if you want to write it, write it. I don't care. All right, so when we talk about temperature, we look at what? What's the key? In order to know if you have a higher or lower temperature, we look to see if the molecules are doing what? Moving. Okay, so temperature is all about the motion of the molecules. And to decide if something has more or less heat, we look to see what about the object? The size, okay? Heat is about its mass or its size. Now, from there, we talked about units and equipment. We talked about the temperature was found with what? Well, that's the unit. Okay, I can write that up here. So the unit for temperature was kelvins. All right, the equipment that we were going to use was the thermometer. All right, and that's where we were when I realized it was like 11:38, 11:39, and I needed to shut up yesterday. And so the unit that we're going to use today when we calculate, which is what we're getting ready to talk about, for heat was the SI unit, which is the joule. Here in the United States, we use the calorie, and we were talking about the equipment, which is the calorimeter. And we will hopefully do a lab with that later in the semester. It's the one I had to cut from the fall because of the snowpocalypse. We had to cut that lab. However, we don't have any calorimeters that we can use. But there's this fabulous invention that we can use that's really cheap. I can afford to buy them for y'all to do the lab. So it's okay. We can still manage to do the lab because the styrofoam cup works as a fabulous calorimeter. So I just go to Food Line, buy us a class set, and we're good to go. I know. Right along with the paper towels I have to buy. Now, the formula for heat is Q equals mCp delta T.
What's this for heat?
Heat.
Is this in our orange?
This is on your orange sheet.
All right.
It's one of three, but the other two we'll learn much later in the semester when we talk about phase changes and learn to read a phase change graph.
Okay, can you read that out again? What's the?
I'm going to tell you what it is.
Equals MP.
Just write it down.
I can't.
I don't know what you said.
You can't write a Q, an M, a C, a P, a triangle, and a T.
I didn't know
I tried to write it.
I didn't know if it was right.
Yeah.
It could be another time.
Her triangles are A's. Like Miss Yalta, when she writes an A, it's a triangle.
Yeah.
You could blame your coworker for our.
Yeah,
It's like triangle has an
Yeah.
exponent, triangle T.
If I want an A, that's an A, or that's an A.
You know, everybody
This
writes.
is an I, and that's an I.
Okay, well,
Hey,
some people write
Yeah.
I's.
so Q equals MCP.
A triangle and a T.
Is it up like an exponent, or did you just accidentally write it down?
It might be slightly slanted because I don't have lined notebook paper.
Okay, well.
Wait, so it's not.
Now, y'all are being a touch critical today.
I don't know if it's an exponent or not.
So it's not an exponent.
No, nothing's an exponent.
It looks like an exponent.
That's why.
It's slightly raised.
It's raised from the P, so.
Sorry, you don't have.
So it's a P like a P.
Right.
Get out your orange sheets.
Yeah.
Turn to page 3. About halfway down.
Oh, the P is the one that's down. The P is down. I need to write it right. I just wrote it in one color. Not too cool.
Oh, the P is
I'm coughing.
See, should fix that.
It looks smaller than the C, people.
But it doesn't look lower than the C. Rewrite it. Now you made me write it in my pretty orange color and itinerary.
Is that small enough?
Yeah, that's good, thank you.
I'm not writing it that size every time we write this equation.
What in the world?
Now, Q means heat lost or gained. Now, just because I said heat lost does not mean it will be a negative number, okay? It will still be a positive number. It is also found in joules.
Oh.
Not that again. M is mass, and it's found in grams. CP is specific heat. Okay, CP stands for specific heat. Okay, it's the amount of heat needed to raise 1 gram of material 1 degree Celsius. Okay, I will talk about what specific heat is in just a minute. Now, its unit is joules over grams degree Celsius. Now, that's CP. The nice thing about CP's unit, if you forget it, is I'm going to show you how to find it on your orange chart. Now, delta T, you should have learned about in math class. What does the triangle stand for in math
I know
class?
it as a sorority.
A lot of people do. It's delta, all right? It means change in, and because we put it in front of a T, it means change in temperature. Now, generally speaking, when you say change in, what math operation are we going to perform?
Any of them to change it?
Multiplication.
Adding and dividing.
Subtraction.
Subtraction. Okay?
Everything else.
Okay? Generally speaking, we're going to subtract. Now, every now and then, the problem will say the temperature increased by blah, blah, and you won't need to subtract. But most of the time, it will give you a temperature of such and such, and it went up to such and such. So when you have two temperatures, you're going to need to subtract them. Or it might say it started at this temperature and it went down to this temperature, and you're going to need to subtract them. Now, before we calculate, I want to talk a little bit about what specific heat is and what it means, and then we're going to do the calculations.
Perfect.
How to rewrite it because the D and C.
I know, the CP was too big.
It was. Let me just look at it.
Should not take that long to white something out.
No, I had to rewrite it.
So C and P go together in that
Yes,
distance.
it's one variable.
Who is this?
No.
You okay over there?
They're not. 10 out of 10 here.
Almost done.
Girl, what you writing?
Paragraph, apparently.
Girl, it's not English. You said it has to be pretty.
We're getting close.
Look, dude, I don't have time for you to color code for days.
I just had to rewrite the equation because I forgot the N in it. I didn't even see the N. Okay, you're good. Go ahead.
All right.
All right.
All right. So what does specific heat tell us? What does it mean? All right. I'm going to use an example of two that we know. All right. If we take water, it has a specific heat of 4.18. And aluminum, I think it's 0.897. Probably should look that up before Annabelle writes it down again. It takes 20 minutes. Color code.
Yes.
Now,
That's what we're
Is
writing.
that how hot it is, what third grade?
how much it takes to raise it.
Oh,
For-
how much it takes to raise it?
Yeah. Now, for all intents and purposes, this is a large specific heat. And this one is a small specific heat. Okay? So water is a large one, aluminum foil is a small one. So what's the difference between the two? How is one different from the other?
One takes longer to get, one is less than one.
Okay,
has a whole number of numbers.
I liked what Nakaya had to say. Say that again, Nakaya.
One takes longer to eat. Oh,
Okay,
one takes
the water heats very slowly.
Oh, I remember that. You ever stayed in front of the
Okay. It heats slowly. What about cooling? Does it cool fast or cool slowly? It cools slowly. Okay?
Yeah.
So, anything that has a large specific heat is going to heat and cool very slowly. So, what does that tell us about the aluminum then?
It heats fast and it cools fast.
Okay.
Oh my God.
It will heat and cool quickly because it has a small specific heat.
So why we use it to put over our place if it does that?
Holds the heat in. We use it as a insulator. But one of the nice things about foil, if you, for example, line something with it, like I use my kids as examples all the time. They hate,
Well,
they hate grill marks on their food. So I put it down on the grill all the time. Well, I want to pull it off or I want to take it off the pan in the oven because I'm lazy that way and I don't like to clean the pans in the oven. How long does it take the edge to cool so I can pull it off the grill? Take a long time? As soon as I pull it away from the heat, the aluminum foil is cool enough I can grab it with my fingers. Okay? Now if it has oil or grease on it, can I touch it with my fingers? No, the oil or grease will be hot. But the foil itself is cool. If you ever wrap bread or something in foil and you put it in the oven, all right, once you pull the bread out, as soon as that foil comes away from the bread, the foil is what? It's cool. You can touch the foil. It doesn't take but a couple seconds. 10 seconds and the foil is cool. But as long as the foil is on the food, the foil will stay hot. Okay, but foil cools and heats very quickly. All right, that's what I'm talking about with a low specific heat. But water, you put water on the stove, it takes a while for the water to get hot. You sit there, you watch it, and it takes forever. All right? But once you take it off and you sit it on the back of the stove because you're done with it, you just want it to cool.
So hot.
The grease and the ingredients in the hot pocket.
Okay.
Okay? Now,
Oh my God.
does everybody have what they need? Because I'm going to pull up some questions that I have typed rather than me writing them.
Go ahead.
At least I think I do.
I just got a quick question. What y'all got back there?
What? In the back? Copier and a storage room area.
Mini
People
fridge.
go in and out so fast, you think it's a trap house.
No, there's the copiers back there. So that's why people go in and out so much.
Oh. It's y'all version of the trap house.
No. The copier's the attraction.
What? You here?
There. Now you don't have to read my bad handwriting.
Right.
Write it down. I'm going to do 2 of them with you and then I'll set you free to do it on your own. That is very nice. It's so attractive.
Thank you. I gotta wait for this white out to dry.
Blow it. You got a lot of hot air.
Hold on.
Oh. What is wrong over there, Herman? What is wrong?
it's nothing.
Okay.
So we could tell this practice.
Yes. Anything you want to, they're your notes. I never collect notebooks. Ever. I don't want to.
Well, then you need to start moving.
At this level, you should be able to do your own notebook.
Color coded in all.
If you want to color code, color code. If you don't want to, you do not have to. All right. So what variable are we solving for if it says how much heat?
Heat.
It's a variable. So are we talking Q, F, CP, or delta T?
Q.
That's Q. Okay? Unless it says specific heat, you're not looking for CP. All right? So since it said heat, you're looking for Q. Okay? So we're looking for Q. That means M, CP, and delta T have to be given in the question. Okay? You don't get it already. We ain't even started.
I know, right?
Right.
So, given that, what numbers do we have up there? Well, we know. 15 is the what?
Grams.
I know it's the grams. Is it the M, the CP, or the delta T?
The M.
Okay, so we're putting it at the M. All right. So, What is the 45?
Right.
What does CP mean? Specific heat. All right. What's delta T mean? Well, it's a change in temperature. So what is a Celsius? All right. Yes is not the answer to any question unless I ask a yes/no question. I'm not asking a yes/no question. So what is a Celsius? Is a temperature unit, right?
Yeah.
Okay. So if these two things are both Celsius,
Right.
they're temperatures.
Okay.
Okay? So what did I tell you all about delta T? We're going to subtract to find the temperature. So we're going to take 67.5 and subtract 45.1. Now, we always want the positive difference. Now, we do not want the negative number. It's always the positive difference. If you subtract and get a negative number, do what with it? You can switch it around or you can just take off the negative.
So it's essentially absolute value.
It's essentially absolute value. Okay? So 22.4.
Are you doing it? Finish or something?
Now he must just like math class.
I don't think anybody.
Now, we have no more numbers, right? Yet we need specific heat.
You look at that orange sheet.
Look at that orange sheet. On the front page, there's a column that says specific heat. So which element is given to you in the question?
Iron.
So look up iron specific heat. And it's what?
Ding, 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 ding.
Now, I'm going to write the units down. All right. If you look at the top column of the specific heat on the chart, this is why I said a minute ago I was going to show you how you could cheat. If you have a moment on the quiz or the test, you know, I forgot that unit was also a terrible point. Look at the top of the specific heat column. What does it say right beside specific heat?
The unit.
It has the unit. So if you forget, you may look it up. Okay? Now, if you look at the units that are here,
Wrong.
all right, when we plug in and calculate, you can get the unit cancellation. Q equals M CP delta T. We're looking for Q. The mass is 15.0. Delta T and CP are 0.449. And then delta T is 22.4. Now,
Hold on.
where did I lose you at?
Right.
It's because I wrote the equation. I plugged in the numbers.
We don't understand.
Q had a question mark, so I just wrote Q.
Right.
M had 15, so I wrote 15. CP had 0.449, so I wrote 0.449. And delta T had 22.4.
Yeah.
What am I going to do to solve?
Multiply.
Okay.
Yeah. What is that? Oh. We don't significant.
In a moment.
Oh.
Now, in checking out our trusted units, what do they have in common?
Temperatures.
So the Celsius will cancel out, the grams will cancel out, and we'll be left with what? Now, the final step is the significant digits.
Oh.
So we multiplied and divided. So we look. Where did I tell y'all we always got our significant digits from? The original question. So how many are here?
Three.
Whoa.
After
Three?
Wait, for real?
Yes.
It's after the decimal. It's after the 5. There are 3. So there are 3 in all 3 numbers. So I need how many in my answer? 3. So I'm going to round that to what number? 151 joules. Now, if you don't round up, if you wrote 150 with a decimal, I would take it. Okay? Questions? Yes, ma'am.
Do we need a round for the exams, like up the written?
What did I tell you all about significant digits?
So, bro, why do we gotta?
You're in an honors class. You have to have extras for the honors way. Not everyone requires extras for the honors way,
Are there gonna be?
but I do.
Is there gonna be significant digits answer choices on it? Because I would choose.
On the test next Monday, yes, there
No, on
will
the
be.
exam.
What did I tell you about significant
They're not gonna be on the
digits?
exam.
They're not on the
So am I gonna at all?
So
At all.
how questions like this look on the exam?
They're just asking you to calculate Q.
Wait, and it'll give me like.
So the answer-
The answer would have been 150.8 or 151. There are no significant digits on the exam.
Wait,
Okay,
there's
so
no
is this a
significant.
makeup? No.
It's one minute.
Right here.
Significant digits, no. For
No,
those
I know
of
this is
you,
the real thing, but.
no, for those of you who want to pursue anything in science, and you have to take college chemistry, you will have to do significant digits. No college chemistry course will skip significant digits.
Sure.
Yes.
They might not bachelor.
For those of you who will never have to take chemistry in your life, you will only have to endure this in this class. It's a hoop for your friends.
We haven't done.
So this is the
If you take AP Chem, you will, and you will be expected to do it on the AP Chem test.
We haven't even gotten into like this.
I'm aware.
February 13th is.
Alright. Second example. You need me to go back? Yes. Because when you multiply, you would have grams here, joules over grams degrees Celsius here, and degrees Celsius here. So when they multiply, this gram is going to cancel. That's in the denominator. This is in the denominator there. Those two are the denominator, and the other two are the numerator. Yes. Yes. No. No. They're in the denominator. All right. Now that I've answered Raquel's question, second example. This one we're doing largely to help those of you who keep telling me, Miss Wall, my math is weak. Okay? I'll give you a moment to write it before I talk.
Thank you.
Like I said, this one is only to help those of you who have struggling math skills. Those of you who have good math skills, you probably don't even need to do this one.
Good. Wait, we still have two others. That's like we still have to do physical.
We ain't getting there. We might get started on physical properties, but we're not getting there. We will, Laura.
Oh, that's.
Do I need to go ahead and put Q equals M equals 2P?
Okay, sure.
Right.
All right, we got it written?
Yeah.
So, what do we know?
The specific is 5.
All right, so the CP is what?
5.2.
Gram.
Oh.
The what is?
We gotta know what.
Oh, we're looking for specific.
All right, we're looking for specific heat, so we're looking for CP.
Is it?
Okay, because I said, what is the specific heat? We are looking for the CP. Okay? Yeah, we don't know the CP this time. Okay? So, what is that 525 this time? Okay. See how it says grams?
Oh, sorry. I thought you said 565.
Okay. Now, that 565 is the what? That's the Q. All right, and what are we doing with that Celsius crap? Yep. Anybody already done it for me?
48.5 seconds. Yeah. All right.
All right, so when you plug in Q is 565.4, M is 525.2, we have CP, and then we have 48.5. Now, what are we going to do?
Which two is that? Yeah.
Most people do multiply and combine like terms, okay? Now, it's not the only way to do it. So if you prefer a different way, then do it a different way, okay? But most people do prefer to combine like terms. There's nothing wrong with doing it that way. But if you want to do it a different way, knock yourself out.
Please do.
But remember, I have no first aid skills if you do that. All we can do is drag you up to the office.
Yeah, Band-Aids.
A very limited number. Remember, we're very poor. They stole my paper towels. I'm probably down to about 3 till I remember to buy some more. I should have. If I'd known they were going to steal them, I would have. But, you know, they've never come back and actually taken my paper towels in all the years. Somebody said they needed a Band-Aid, or we just asked them.
First of all, I said you have Band-Aids, not do you have Band-Aids.
Oh, yeah, I have like 3. I'm down to that many. The ones that I've purchased, I'm out. That's the ones the school gave me last year.
Oh, sorry. You have to buy that like. Oh wait, I read that right.
All right, what did we get when we divided that?
A big.
Always 0 to
It's a big number.
Because you really do.
unless you combine or whatever.
I don't think I punched that in right. Let me do that again. All right.
I don't know.
This isn't even.
All right. That's enough numbers.
I'm tired of it.
So, this time, you have
A big.
a whole bunch of numbers we need to round off. Look at your units. They have anything in common?
No.
Got to keep them all.
God almighty.
Okay? So when we write the unit, we're writing joules over grams, degrees Celsius. We're keeping them all. Now, if you can't remember that, where did I tell you you can find it? An orange sheet. Now, look at your units and your numbers up there. What can you tell me? How many do we need?
3.
So, does this 0 count?
No.
So I need these first 3 numbers right there. So 0.0222 joules over grams degrees Celsius is my specific heat.
Wait, what was that? The 9 rounded up.
The 9 rounded the 1 up. But if you wanted to leave it at a 1, it's fine.
The 0 doesn't count.
That 0 is a placeholder. That doesn't count. That's a placeholder. Okay? Everybody good?
No, wait, don't. Wait.
Wait.
Do you have another question?
I wasn't going to. Why?
This is dumb.
What's dumb about it?
Like, no reason. It's just
I prefer.
So if I gave you that, would you be struggling?
Yeah. Wait, no, that's right.
0 point.
Somebody said I need to wait.
Yes, please.
Wait.
Okay,
Come on.
I don't think this wall light.
It's not
Okay, this wall. It's sure.
Are we done now? I gave you.
It's like 2 more seconds.
Hey, where is it? So wait, why would it be 0.0?
Because we need 3 significant digits, because that's the least number, right? So that's why I rounded to 3. This is a 1, and that 9 bumped us up, but you could just round off to 221, and that would be fine. That's a billboard, and that's a placeholder.
So today that the significant digits of all of the numbers in the equation?
Yes. Just go back to the original problem, and who has the least?
Let's do today?
Yes.
Okay.
And you did 3 things.
Extra credit.
Girl, right.
If he does what he did last week, he said, look at the papers. That's why I made my outlines extra long.
Okay.
Girl.
He read it and then.
I got
No, on the keyter.
All right. You will have homework with that this evening.
3 pages.
Whoa. This 4? No.
Yes. Now, we're going to do 3 vocabulary words before we leave today. It should be reviewed. Should be easy. Yep. This is something I just sort of assume everybody knows. But let me not make that assumption. It goes with physical and chemical properties, but let's just make sure everybody knows these words. Yes? Just label it physical and chemical properties and put it under there.
Or no, I thought it was vocab.
Write vocab for all I
Whatever
care.
you want.
They're your notes.
Yes.
I'm going to say that like 400 times between now and June, maybe more.
So, physical, chemical
Properties.
properties. Yeah. No, because tomorrow we're probably writing one of
She does this in every
Now, somebody tell me what matter is.
Take up space.
Anything that has mass.
Me too.
I need to do well. That's today.
Oh, air has mess.
I don't really care what you're doing tonight. Now, anything that has mass and takes up space. So, if I was to ask you to give me some examples of things that are matter. All right, give me 3 things that are matter.
Calculator, Annabelle, and Kaya.
Okay.
Those are the first things I saw.
All right, instead of labeling Annabelle, we'll say people. And what was that last one?
Pencil.
Okay. Now, give me some examples of things that are not matter.
Space.
Imagination.
Abstract
What?
ideas.
Okay, y'all have missed the boat. That is not going to be on anything you're ever going to see.
Air.
Air. Air goes over here. Okay? If air was not matter, I don't know how you got to school today unless you walked.
Right.
Okay? Because we use air to inflate tires. Okay? When I move through the room, we push air out of the way. Okay? Oxygen, we inhaled.
Okay.
Okay? We exhaled. For those of you who said that, we exhaled what gas? Carbon dioxide. Your biology teachers would be horrified with some of that stuff y'all yelled out. All right, yes? Light. Light would be a fabulous example of something that's not matter. Okay? Give me something else that's not matter. Smoke fits over here. All right? Give me something else. Gravity I can put over here. Y'all make a lot of it because there's so many of us.
Oxygen.
All gases.
Life. Yes.
All gases are going to be matter. They have a mass. It's very small. They have a mass, and they take up space. Okay? So, y'all make a lot of what? Sound.
I said we need it.
Y'all need to say it louder back there. Okay? Imagination is not what I'm hunting for. Yeah. Now, see if you can't come up with 2 more to put on there tomorrow. And write down these 2 words. Mass and weight. I want to know the difference. Listen.
I'm not writing anything because
I do not want to know the definition. I want to know the difference. Write it in pencil.
Right.
too late.
Well,
It's too low.
Wait, so you wanna know what's the difference between this?
Mass and weight.
And what was the question you said?
2 more examples up there of what is not math. And do not tell me it's imagination.
Imagination.
What about that shot?
That's not any better.
Not relationship studies. That's not a case.
That is not what I'm looking for.
Cloud.
Oh, yeah.
Now, y'all studied the water cycle ad nauseum in middle school. Do not tell me clouds or not math.
Well, I mean, if they don't have.
I'll be right back to your.
Okay.
All right, other than Takira, who got this? Yes, there are only 6 questions. Why are y'all yelling all of these? Carol, you know how to get to the next place? Okay, put my calculators up.
Oh, I put yours